So I'm going to go over reversible inhibition with you. So the first thing that I want to explain is the way that we graph the inhibitors is through the Lineweaver-Burk plot. So that is actually the inverse reciprocal of the Michaelis-Menten equation. So just a few details about the graph. The slope of the graph is actually your Km divided by your Vmax. So a good way to understand what is happening in these graphs is to look at both the y and the x-intercept because they represent different characteristics of the inhibitors that you guys need to understand. So your y-intercept is your 1 over Vmax, and your Vmax is the speed at which your enzyme is functioning at its maximum capacity. And then your x-intercept is the -1 over your Km, and your Km represents your substrate's binding affinity to that. So just by looking at your y and x-intercept and seeing if there's an intersection there or if there is not an intersection, then you know a lot of characteristics about these inhibitors. So the first type of reversible inhibitor that we're going to go over is your competitive inhibition. So this is when your substrate is competing with the inhibitor to bind in the active site of your enzyme. So your inhibitor is lowering your substrate's ability to bind as frequently, basically. So because of that, there's not going to be a change in your Vmax since the conformation of your enzyme is still the same. So that's why you see that there's going to be an intersect right here on your y-axis because there's no change in your Vmax. But there's going to be an increase in your Km or your binding affinity because now there is both an inhibitor and a substrate that can bind to the active site of the enzyme. So now that there's more molecules present, more of them are going to be binding to that active site. So that is why you see in your x-intercept, there's going to be like a change in it, an increase. So the second type is your uncompetitive inhibition. And so that is when your inhibitor is binding to your enzyme substrate complex, but not the active site of the enzyme. So this is going to cause a conformational change in the enzyme that lowers the affinity of your substrate to bind to the active site because now there's a change in that shape of it. So that's why you see that there's going to be both a decrease in your Vmax and a decrease in your Km. And that's due to that conformational change. So now that it's not the right shape, the enzyme is not going to be able to function as effectively. And same with the Km, your binding affinity is now going to be lowered. So that's why you see in this graph is actually parallel lines because both your Vmax and your Km have lowered. So your slope is still going to be constant. So the third type is your mixed inhibition. And this is kind of a combination of non-competitive, of uncompetitive, and competitive inhibition because your inhibitor can bind to both your enzyme and your enzyme substrate complex. So you see a decrease in your Vmax because just like in your uncompetitive inhibition, there's going to be a conformational change when it's binding to that ES complex. So that's going to lower its ability to function at its maximum capacity. But for your Km, your binding affinity, there can be either an increase or a decrease depending on that ratio of how much of your inhibitor is binding to your enzyme versus how much of it is binding to your enzyme substrate complex. So for this one, you see a change in both your y-intercept and your x-intercept. There's a special type of mixed inhibitor called a non-competitive inhibitor, and that one it's actually an equal ratio of your enzyme and your enzyme substrate complex being bound by that inhibitor. So in this special case, the x-intercept has an intersection because there's not going to be a change in your Km. And that's because when it binds to your enzyme, there should be an increase, and when it binds to your enzyme substrate complex, there should be a decrease. So they cancel each other out. So then there's no change in your Km. But there's still going to be a decrease in your Vmax due to the conformational change. So I hope this helped. Thank you.